Coastal cities have long been centers of commerce, culture, and innovation. However, these vibrant hubs now face unprecedented challenges such as sea level rise, increased flooding and erosion due to climate change, extreme weather, more frequent and intense storms and hurricanes, urban overcrowding, pressure on infrastructure and public services, and environmental degradation, the loss of natural buffers like wetlands and mangroves. To address these challenges, urban planners and engineers are rethinking how coastal cities are designed, built, and maintained. A holistic approach is key. Modern planning integrates land use, transportation, infrastructure, and environmental management. Green infrastructure, incorporating parks, wetlands, and permeable surfaces, helps manage stormwater and reduce urban heat islands. Mixed-use development encourages local economies and reduces the need for long commutes, lowering carbon emissions. Elevated structures, buildings, and critical infrastructure are designed to withstand flooding and storm surges. Adaptive materials, the use of flexible, durable materials that can adapt to changing environmental conditions. Smart technologies, sensors, and data analytics enable real-time monitoring of infrastructure performance and environmental conditions. Innovation at the water's edge, floating cities represent a radical shift from traditional urban design. Instead of resisting the water, these cities embrace it. Modular and adaptable structures are built on floating platforms that can rise and fall with changing water levels, reducing flood risk. Sustainable energy floating cities often incorporate renewable energy sources like solar panels and offshore wind turbines. Self-sufficiency. Designs frequently include systems for water purification, waste recycling, and local food production. Community-centric design emphasizes public spaces, connectivity, and flexible living arrangements that can adapt over time. The Netherlands, known for its advanced water management, the Dutch have pioneered many technologies and design principles that inspire floating city concepts. Pilot projects, cities like Amsterdam and Rotterdam are experimenting with floating neighborhoods and infrastructure as part of long-term climate resilience plans. Ecosystem integration. Balancing development with the preservation of marine and coastal ecosystems is critical. Carbon footprint. Even sustainable materials and technologies need to be assessed for their full life cycle impact. Cost of innovation, cutting-edge designs and technologies require significant investment. Community acceptance. Successful projects need to involve local communities in the planning process to ensure that innovations meet social and cultural needs. Policy and governance. New models of urban living demand updated regulations and international cooperation to manage shared water resources and infrastructure. The future of coastal cities lies in our ability to combine technological innovation with sustainable planning. By embracing adaptive designs such as floating cities and integrating smart infrastructure, coastal urban centers can evolve into resilient communities that thrive even in the face of climate change. Design trade-offs. How can engineers balance the need for resilient infrastructure with environmental conservation, community involvement? What strategies can ensure that local residents are active participants in the transformation of their coastal cities? Future innovations. Beyond floating cities, what other innovative solutions might help coastal cities adapt to rising sea levels and extreme weather? This overview provides insight into the exciting, evolving field of coastal urban planning. By exploring both traditional engineering solutions and visionary ideas like floating cities, we can better understand the path toward sustainable, resilient coastal communities for future generations.